Okay, I've referenced this a few times, but let's just finish off by talking about why blood O2 is generally unaffected by dead space, and then the circumstances where it will be. So the caveat to this is unless there is a very large increase of dead space, therefore you have decreased alveolar ventilation. Remember, the equation here is that your alveolar ventilation is equal to your tidal volume minus your dead space. So when your dead space is very high, you use up all your tidal volume for dead space and essentially have no alveolar ventilation. So this would be causing low O2 gas exchange area. So our very good example of this is with cardiac arrest, where you drop your cardiac output to nothing, so your flow is 0, and you're ventilating both lungs, which are picking up no oxygen, also getting rid of no CO2. But until you improve the flow to your lungs, you will not actually be oxygenating. To show that at the alveolar level, your alveolar ventilation here is 0 because you have no flow to these alveoli. As long as you do still have a reasonable amount of alveolar ventilation, you'll be breathing in oxygen, and then it will go into your pulmonary capillaries. So when you measure your final O2 content here of the artery, this blood is unaffected by the fact that there was an area of lung that was not being perfused. And your oxygen saturation will be 100% if it was being saturated 100% here. So, dead space does not cause hypoxemia unless you have high dead space and your alveolar ventilation is relatively low. So that's interesting and good to know, because you could have someone presenting with a PE who does not have hypoxemia, and that's actually very consistent with the mechanism of dead space. But you can get hypoxemia with a PE, and that could be because of decreased alveolar ventilation, or you also can have infarcted lung or damaged lung tissue around where the blood was supposed to be going that's blocked off by the embolus, and that will cause shunting or bronchospasm, which would be reasons for your blood O2 saturation to drop. By the way, bronchospasm causes dead space in a similar way to the positive pressure or PEEP example I showed above. Anyways, if you can remember that dead space is from low perfusion, and then anything that will cause low perfusion to the capillaries that go to your alveoli will result in dead space, you're off to a good start.